So, in our last class, as I mentioned about bound charges, free charges, polarization, etc. So, I'm just continuing from there. So what exactly is a polarization? As you know, each molecule now act as a dipole. Each molecule is acting as a dipole. So, net dipole moment, net dipole moment of a dielectric substance, okay, measured per unit volume is actually called as polarization vector. I repeat, what is polarization vector? Polarization vector is defined as the net dipole moment of a substance per unit volume. Suppose if there are n dipoles, n refers to dipoles per unit volume. So the net dipole moment is defined as, okay, in a volume delta V is defined as sigma I is equal to 1 to n delta V, not n. Why? N refers to per unit volume. N delta V refers to number. Pi bar. By doing all, and the total volume of the very specimen that I have taken is delta. By doing all, I will get net dipole moment per unit volume. And this is called polarization vector. This is called polarization vector. Dipole moment is represented with small p, and polarization vector is represented with capital. And capital P bar is polarization vector. Okay. When I am writing P bar, I am speaking about at macroscopic level. Even microscopic, you are speaking about a molecule. The macroscopic level, you are speaking about collection of things. See, summation chesanu. Done summation. That's the introduction. Now you know what is bound charges. Fine. Now I want to understand something like this. Now I have a dielectric material. That's a dielectric material. Imagine that this is a dielectric slab. That's a dielectrics lab. In that dielectrics lab, I am just taking a small volume. Hope you understood. I am focusing on some macroscopic area of the dielectric material. Any doubt till this point? Right. Today's theory, what is hardcore theory? Maybe first time in your this thing you are following such a hardcore theory area, and this is the reason why I'm recording this, so that at a later stage, if you have any confusion, you can refer this. Now I am assuming this is a normal to that portion, which I will represent it as a delta x. And imagine that in this region, you just have an electric field available like this. Electric field available like this. Any doubt? Sure. Right. Now you are considering this small patch delta x. Right. Good. There is no electric field for a while. For example, I am taking some number n here as the number of charges per unit volume. Now net is zero. That all of the entire volume is neutral in the absence of any electric field. No, I told you a molecule kind of arrangement in this, a minus and a plus. Let the distance between the charge separation is d, like a dipole. Now what happens is that this dipole, which are earlier randomly scattered, now orient along the direction of the dipole. As a result, if I take this as a reference, the surface part, on the surface, these molecules exist actually. Delta S area, these molecules exist actually. When you apply electric field, orientation takes place. Okay? Because of this orientation, okay, the positive side will move above the surface, the negative side below the surface. Because of the orientation, this will take place. Which means I can confidently say that this is d by 2 cos theta. This is also d by 2 cos theta. Yes. That is the direction of the field. I am not giving anything between delta S and E. I'm just telling you on the surface, which are the molecules are like this. orienting like this. This angle is theta. Sorry. Is this okay now? Clear? Any doubt, boys and girls? Sure. Right. Now, what is happening over here? The dipole moment here you can define simply as a QD, one molecule for one molecule. Now, I am uttering something which you please take into very serious and don't compromise. Any charge lying within a distance of d by 2 cos theta, I am speaking about something in this zone. Any molecule in that portion will now cross upwards. Any molecule in this zone will cross downwards because of the application of the field. Earlier, maybe the molecule is like this. Because that you have applied electric field. Because that you have applied electric field. 1 minute. This is a thing. Because you have applied electric field. That is what happened. Polarization is this. Right. I am just writing the term very clearly because this is our notes which we are expected to save it for a longer time. So therefore, any charge lying within a distance of d by 2 cos theta must have crossed downwards or upwards. If it is a delta Q, upward, plus charge, upwards. If it is a minus charge, downwards. As I mentioned, is the number of charges per unit volume. Positive charge help area delta S. D by 2 cos theta is volume. Now this is a charge number, okay, into Q. Any doubts? Serious గా చూడు ఏం problem. But give me answer problem. చూసుకో. Orient. Similarly, negative charge crossing downwards. Why I am writing delta QB, you know clear reason. They are not free charges. They are bound charges. Minus plus. Bonding is there. They cannot separate. You can orientate. You cannot separate. If you separate, it's no longer, it's no longer, it's no longer a dielectric, man. If it is no longer a dielectric, already we have worked related to these dynamics in current electric, drift velocity, etc. like that. Now you know clearly. Now tell me what is dipole uh, 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 net. Please be very careful while I am writing this step. Net sum of charges crossing outward along the direction of the north. That is delta QB plus delta QB minus. By the way, this is delta S T cos theta into N. Now I know very clearly polarization vector. The polarization vector P bar is N it is in which direction? Direction of the electric field. Actually. N this is that is a dielectric polarization vector. So it is nothing but if you allow me to write N Q P theta. అవును ఒక్కొక్క డైపోల్ QD into N per unit volume N theta. So from this I can say this already I know. We know this. Now delta QB can be written as NQD into NQD into delta S into cos theta. So delta QB is P bar dot delta S bar. For this, I have given you this expression. Now, please tell me any doubt. If it is very small, care must be taken, that is polarization vector, not dipole. Please. So it is capital P, not small p. What is the difference? Capital P refers to dipole moment per unit volume. Small p is dipole. Now, honestly, how many have followed this? Raise your hands. How many is still having doubt? Raise your hands. Put down. How many still having doubts? Please raise your hands. I'm asking again. How many still have any doubts? Yes. If I know polarization vector hereafter, I can give you bound charge. You are asking why you require this relation. Now, in Gauss law, if you give me E bar at a place, I can give you the charge enclosed. Same I am going to use here. I want to find a relationship between polarization and the bound charge. Like in Gauss law, integral E bar dot ds bar is 1 by epsilon naught charge. Right. Any doubt on this? Right. Now I am going to apply this. Okay. Right. This is a very important thing that we have done right now. Now imagine this particular equation holds not only for that, you can use bigger volumes also. At a microscopic region, I have applied this. You can expand this to the total region also, which means this equation holds for a very small patches, because the portion which we have selected is a patch inside dielectric. So to find, remember this term I am writing, to find net charge flows out of a closed surface. What? What to? That is for small patch I have given. Yes, exactly. Integrate. For this purpose, imagine that this is some portion because of the electric field or whatever is the region. So you have a bound charge. That is crossing this surface. This is in, and what I have written is out. So integral d bar dot ds bar is you play it for a small portion here. Even you can apply it for full one. Okay, right. Next, we know susceptibility polarization is a consequence of the field applied by you. You have applied some field, consequence is polarization. Cause is electric field, effect is polarization. So you should relate that. So therefore, anytime polarization vector is the strength of the applied electric field. Remember, when you are writing E bar, this is net electric field inside a dielectric. So the polarization is directly proportional to E bar. And the polarization vector is equated to that by using a constant called chi. That symbol is chi. Greek epsilon naught chi. Why epsilon naught? E bar dimensions, P bar dimensions are different. P bar dimensions charge per unit, charge by length square. Electric field dimension 1 by 4 pi epsilon naught, charge by length square. So left side, right side to equate, you require SI units only. So to make multiply epsilon naught E, it will become P dimensions. Okay. So left side is effect, right side is cause. And this constant of proportionality is called electric susceptibility. It's a constant, depends on the nature of the material, and more polarization means more susceptibility, which means what I can write here is, for example, I told you polar and non-polar dielectrics. Polar dielectrics will have more susceptibility, and susceptibility is inversely proportional to temperature also. Yes, temperature increases, susceptibility decreases. Susceptibility is a measure of the strength of polarization. It depends purely on the nature of the material, right? So we will use sometime called a term epsilon r, which is also called as K, dielectric constant. That is called dielectric constant, and you know the definition of this is epsilon by epsilon naught. That's the definition. And they are related to susceptibility as we will derive this in magnetic magnetism. Actually, I don't require it right now, but safety purpose I have. Whether this falls under our syllabus or not, no idea. Depends on the paper set. Safety purpose I have. Now tell me how many terms I have introduced right from the beginning. Polarization vector, susceptibility, and relation between dielectric constant and susceptibility. That's it. So already in the last class, I have discussed a lot about, I think in a video class, I have discussed about Gauss law in dielectrics. But please confirm whether I have done Gauss law in dielectrics or not. Yes or no? Sure. So Gauss law in dielectrics, anyway, I will write once to conclude. Not, I don't derive it, just Gauss law in dielectrics. You will simply write this as epsilon r times E bar dot ds bar is 1 by epsilon times q free. Do you remember this? Boys and girls, what is E then? In that, what is E? What is E then? E is net electric field. I'll give one more expression also in the same. Hey, I'm cheating actually. I'm writing not a new one. Already the one which you know. Bound charge and closed field. Right. Because Gauss law, we don't care what is outside. చెప్పండి ఇప్పుడే ఫ్రెష్ susceptibility epsilon E bar dot ds bar is equal to minus QB in. Yes or no? And one more important point. You already know. Net. Okay. For this, what is Gauss law? Q net, which is nothing but Q free plus Q bound. But anyway, Q bound in మళ్ళీ అందులో కొత్తగా చెప్తున్నది. Now tell me how many do not know equation 1. Raise your hands. Sir, first time I am seeing equation 1. Raise your hand. Sir, first time I am seeing equation 2. Raise your hands. Sir, I am seeing first time equation 3. Raise your hands. Actually, equation 3 is the oldest, which is what you know earlier stages. Freshly taught you 2. 1 also in the very first class. Now you take all the sum. 1 plus 2, all these things. You know, trust me, you will get the same. What is that? Finally, what you will get is dielectric constant, epsilon r, otherwise, into E bar dot ds bar is Q free by epsilon. I got a 1 from these 2 equations only. I have simply added those 2. 2 plus 3. LHS, you add 2 plus 3, man, what you will get? Epsilon naught times 1 plus susceptibility gives you what? Yes or no? That's all. Okay, any doubt? When you are applying Gauss law and when you are multiplying dielectric constant here, make sure that you are drawing here Q free, not the bound charge. This one, only you should consider this charge. Yes, exactly. When you are drawing net electric field, take only free charge. Any student having problem till here, please ask. Right. And some important caution based writings that I am going to hear. Okay, fine. When you are allowed to use this, not for any daily. This is used only for, yes, very good. Homogeneous isotropic. Homogeneous isotropic dielectrics. For homogeneous isotropic dielectrics, K becomes a constant and it has nothing to do with the integration. Okay. When you are applying Gaussian surface in material matrix, means some portion is in dielectric, left hand part is in conductor. In this case, is zero. If you are applying this in conductor, zero, because you don't see polarization in conductor. Yes or no? I am repeating my terms again. Please go through. If you are taking the Gaussian surface which is passing through the material matrix, metal, I mean, then susceptibility times E bar dot ds bar must be taken as zero at that point. These are very cautious point. We will feel that they are not serious. When I am applying in a problem, you will face the concept. Any doubt? So, when I am teaching some application oriented, you are very comfortable, active and all that. When I am teaching this, I can see a drowsy faces because you don't wait things in this. But when I am dealing problems today, you will face the consequences. Next important term, I think when I am writing Gazala, I have used this. Here, E naught refers to the field only due to the free charge. Field only due to the free charge. Next. So what happens? Inside a dielectric, so the green colored are metal plates. They have given some positive charge over here. Okay. Because of this, I am not writing everything here. Some polarization takes place. That black color arrow represents polarization direction. Okay. Polarization direction. Am I right? Am I right? Wrong. Actually, what is the direction of polarization vector? Negative charge to positive charge. Why? Why? Dipole moment is the direction from negative charge to positive charge. So therefore, that's the direction of dipole moment. Okay. So now dipole moment, but actually because of the distribution of the charge, there is an E due to polarization. E due to free charge. Okay. So this E due to polarization can be given as, just now I have given one relation. What is that relation? Earlier, I have just given one relation. What is that relation? P bar is okay. Now, now E net. Mm. E naught. E net అంటే మరి అంతే. Okay, okay. Got the point. Without placing dielectric, that's the situation. After placing dielectric, what is the situation that I need to discuss? మా పాత్ నోట్స్ ఉంది ఎవరి దగ్గర, అది కొంచెం నీట్ గా రాశాను. Right. So here, E net, correct. It's not E naught. E represents the net. So Please find this difference hereafter. Vectorially, I have shown you what are they. Please find the difference. Don't get confused. What is E net, you know? E naught bar minus E naught bar plus or E naught minus E polarity. Otherwise. గాజులో ఈ నెట్టే ఎక్కడెక్కడ రాశాను. అవును, ఇది వితౌట్ dielectric. Don't get confused. Right. Next. All these things are theory which is related, which is required for us to do problems ahead. Right. ఇప్పుడు ఇక్కడే చూడండి, ఈ పోర్షన్ లోనే డైరెక్టరేట్ లోనే చూడండి. మనం ఏమని చెప్తున్నాం? Now, you take a portion here. Small portion. On dielectric, you know this all. Okay, na? Any confusion in both? Any confusion in both? But just now we have derived here something. QB, DQB is P bar dot TS bar. So therefore, you can write DS bar like this. N cap means a vector okay, and this is the direction of polarization at that point. Okay, right. Agreed. Please confirm. Please confirm. ఉండి ఏదో తీటానో ఏదో ఒకటి ఉంటుంది అనుకో. At that point, that is the in this case, n cap is 0. In this case, n cap is not 0. Okay, na? Now tell me, what is this term called? dqb by ds called sigma b. So therefore, hereafter, sigma bound can be written as p bar dot n cap. Any doubt, please ask. Same, you can even you can express here in this case also. At this point also you can express. What is dipole polarization here? Tell me. The total bound charge into a distance, thickness of the dielectric slab. What is this dipole moment by volume? Okay. What is this? You are asking what is a Q bound? Okay. Or this is nothing but sigma bound. Okay, na? But you are not convinced with my expressions. No issues. What is polarization here? Polarization here is susceptibility times epsilon naught E net. E net. E naught minus E naught by K. Correct? What is susceptibility? K minus 1. So which means polarization vector here is epsilon naught E naught 1 minus 1 by K. What is E naught here? Simply Q free charge. Epsilon naught A times 1 minus 1 by K. So therefore, what is P here? Q free by A times 1 minus 1 by K. Q free అంటే ప్లేట్ మీద ఉన్న ఛార్జ్. అంతేగా? ఇక్కడ దాకా రైట్ సైడ్ ఏమైనా మిస్టేక్ ఉందా? టూరా? దీన్ని ఏమని పిలుస్తారు? P is sigma free times 1 minus 1 by K. ఇప్పుడు మనం సిగ్మా బౌండ్ కూడా ఇదేగా చూపించేది. మరి మైనస్ వస్తుంది కదా సిగ్మా బౌండ్, మరి ఇక్కడ ప్లస్ వచ్చింది ఏంటి? అందుకే పీ క్యాప్ డాట్ ఎన్ క్యాప్. మీరు ఇక్కడ చూసినప్పుడు ఎన్ క్యాప్ డైరెక్షన్ ఇది, ఇక్కడ చూసినప్పుడు టీ బార్ డైరెక్షన్ అది. పీ క్యాప్ డాట్ ఎన్ క్యాప్ ఏమైంది? మైనస్. సరిపోయిందా సరిపోలేదా? నేను ఇచ్చింది మ్యాగ్నిట్యూడ్, డైరెక్షన్ ఆల్రెడీ మీకు తెలుసు. కాబట్టి ఇప్పుడు మీరు ఇదంతా ఒప్పుకుంటారో ఒప్పుకోరు. ఇంక నుంచి సిగ్మా బౌండ్ అంటే ఏం చేస్తారు మీరు? పీ బార్ డాట్ ఎన్ క్యాప్. ఒప్పుకున్నారా ఒప్పుకోలేదా? నేను పర్ఫెక్ట్ గా డెరైవ్ చేశానా చేయలేదా? వాట్ ఆల్ ఐఎమ్ డూయింగ్ నౌ ఈజ్ నాట్ అవైలబుల్ ఇన్ యువర్ టెక్స్ట్ బుక్స్, ఈవెన్ ఇన్ హెచ్సివర్. Even whatever you take, thing study material, all that, it is not available. So that is the reason why I'm slowly teaching this. And I just want to make sure that you follow every step in this. This is the end of part 1 of the video.